All right, welcome back to Mystery Eat Math, and this is where we're going to make some more mystery of math into past tense. And I thought, since we have a sub today again, I gave you some help on the one worksheet. I'm going to give you some help on this other worksheet that he should have handed out, called Properties of the Rectangle, Rhombus, and Square Practice. Okay, so I'm just going to show you the first problem from each section, just to give you a little bit of a start. But before we do that, let's talk about these. First, let me turn it the right way, and let's talk about these true-false questions that are at the top. I'm not going to tell you the answer to those questions, but I think you'll be able to figure it out, perhaps, when I remind you of this. We started talking about parallelograms. Then we went to rectangles. Then we talked about rhombuses and squares on the same day. Now, there are many things which are called parallelograms. All of these, actually the entire page, what you see here, all of these are quadrilaterals. And all of these quadrilaterals are parallelograms. Right, but you got a square, which is like the ultimate parallelogram. It's the ultimate quadrilateral. Okay, and the square is actually a rhombus and is a rectangle and is a parallelogram. Okay, so squares fit all those categories. They meet all the rules. All right, but when I come up to this level, now the rectangle is not necessarily a square. There are plenty of rectangles that are not squares, but all squares are technically rectangles and technically rhombuses. Okay, same thing exists between rectangles and parallelograms. All rectangles are parallelograms. They meet all the rules for it, but not all parallelograms are rectangles. Same thing with a rhombus, okay? So it starts here. Everything on this page is a parallelogram, but only certain things are squares, and a few more of the things are rectangles and rhombuses. Okay, so hopefully that helps. Now, let's move to a couple of the questions that I picked. This is number 7, okay? If you look there, rectangle FGHJ, well, is a rectangle, right? So I'm going to go through here, and for this rectangle, I've got the red numbers are the different angles, and the black numbers are the angles that I was given in the beginning. So the first one that jumps out at me, anytime I see a vertical angle, I don't know, I've just kind of trained myself to lock that one in. So I see 126 degrees here, and angle 5 is right across from that. I know already that angle 5 is 126 degrees. That's super easy. Okay, now with rectangles, you need to look very carefully at how the diagonals work. Okay, and the diagonals, they do not bisect these angles. So if I look here, angle 1 and angle 3 are not the same. But because the diagonals are the same length, they match each other. We've got parallel sides. We've got same length diagonals. This creates a situation where, and then if these bisect each other, that means this length is the same as this length. And when we have a triangle that two of the short lengths are the same, well, the angles are the same as well, right? It creates an isosceles triangle. So I know that this angle is the same as number 2. I also know on the other side, the vertical angle relationship when we come across, well, these are parallel, and we have this same relationship. So these two triangles, the top triangle and the bottom triangle, are congruent to each other. And with CPCTC, corresponding parts of congruent triangles are congruent. That means this angle over here and this one over here are the same as these angles here. So if that one's 27, that means angle 1 is 27 and angle 2 is 27. All right, and that one, if I needed it, would also be 27. Okay. Now, we're trying to set up the same thing on this side because these 4 are also going to be congruent. So whatever value I come up with, 3, 6, or 7, they're all going to be the same. The trick is going to be finding angle 4. All right, so, well, here I have a straight line and I have an angle. This whole measurement is going to create 180 degrees. This is a linear pair. Okay, so a linear pair always adds up to 180. So if I take 180 and subtract 126, I am left with 54. And that's what angle 4 is. All right, now, if I know that angle 4 is 54, let's go ahead and write that in, then I know that these 3 angles are going to add up to 180. And I know that these 2 are going to be the same measurement. Okay, so what I'm going to do is I'm going to take 180, I'm going to subtract 54, and I get 126. So now I know I've got 126 degrees to split evenly between these 2 angles. So I'm going to divide 126 by 2, and I get 63. So angle 3 is 63, angle 6 is 63, and angle 7 over here, all 4 of these are congruent, so that is also 63. All right, we have answered that question. Now, let's move on to this one on the bottom. Okay, now instead of messing with angles, we're messing with side lengths. Okay, we've got a side length of 12 and a side length of 5. And then we have this half of a diagonal is 6.5. Because it's a rectangle, the diagonals are the same length, which means the half diagonals are also the same length. All right, so let's see what we got. FG is up here. All right, and they're opposite sides, which means they're going to be congruent and parallel. So I already know that that's 12. So FG equals 12. GH is across here. Same relationship between these two as exists between these two. So this is going to be the same. It's going to be 5. All right, JM. Now JM goes from the corner halfway. It's a half diagonal. All right, all 4 of these half diagonals are going to be the same measurement. So I know that JM is 6.5. GJ, okay, goes from here all the way across. So if I know the half diagonal is 6.5, then the full diagonal would be twice that. So 6.5 plus 6.5 is 13. Okay. Now FM goes halfway. Well, that's another 6.5. And then finally FH goes all the way across, just like the GJ. So they're the same because it's a rectangle. So that's going to be 13. This one's done. Pretty simple. All right. Let's put that aside. And the last sheet I have here for this worksheet, I think that should be plenty for you to get started, has to do with a square. Now, the first thing that jumps out of me here, 3x degrees over here. I know that that's going to be 90 because it's a square. All right, and 3x, so I set 3x equals 90, divided by 3, x equals 30. So let's, I think there's a spot for that. Yep. And I mean, I just rolled right into that, but really I had a couple that were even easier than what I just did. Angle F is 90, and angle G is 90. Okay? All right, now let's go to Y. And with Y and JH, I'm dealing with these two values here. So it's a square, which means all 4 sides are congruent. So this side is going to measure the same as this side. Pretty simple. Set them equal to each other. 15y plus 2 equals 11y plus 10. I'm going to move the y's together, so let's move this one left. Those cancel. Now I have 4y plus 2 equals 10. Subtract 2, 4y equals 8. And when I divide both by 4, y ends up equaling 2. All right, now I need to find the length of, not the y value, but the length of JH. So I'm going to substitute 2 for, take 11y plus 10. Now I put 2 in place of the y. I'm going to use parentheses to do that right. So now I have 11 times 2, which is 22, plus 10 is 32. All right, there's all of those. Now let's go to this last part. And there's 2 questions that it asks you to draw and label. Okay, and it describes it as saying ABCD is a rectangle. Okay, that's pretty generic, and I can draw a pretty generic rectangle. I could start naming really anywhere I want to. I like starting in the upper left. Okay, but you could start somewhere else if you wanted to. All right, but you do have to name it in the same order. You can't just go A, B, C, D or something like that. Honor the order that it's laid out in. Okay, so AB. So for my drawing, this is AB. And that's going to equal 2x plus 5. Okay, and CD is this one right there, and that's 5x minus 13. Well, I'm kind of already seeing what I need to do. I need to find the length of CD, but the way I'm going to do that is find x first and then translate that into the formula. And since the first property of rectangles, or I'm sorry, of parallelograms applies to rectangles, it says opposite sides are congruent and are parallel. Well, the thing I'm interested in is that they're congruent, meaning they're the same length. So I can say 2x plus 5 equals 5x minus 13. All right, let's see. I want to move the x over there. So minus 2x minus 2x. The reason I do that is because I want a positive value for the x. I don't want to deal with negative 3 over here. So to me, that's easier. So I've got 5 equals 5, not 5, 3. 3x minus 13. Okay? And then I'm going to go ahead and move 13 over there. So plus 13, and then I get 18 equals 3x. Divide by 3, x equals 6. Haha, there's my answer, right? Nope, that's not my answer, because it's what x equals, but I got to find what CD equals. Okay, so I come down here. All right, 5x minus 13. So I'm going to substitute 6. So 5 times 6 minus 13. That would be 30 minus 13, which, if I put in my calculator or work it out in my head, equals 17. And that is the answer for CD. Okay, I hope this helps. The worksheet hopefully should lay out pretty similarly to the ones I've already done for you. Good luck. Have a great day. Be kind. And I will see you Friday.